Alright, so in this lesson we'll talk about the dot product, also called the scalar product, and this will allow us to find the angle between vectors, and we'll talk about the different forms of equations, vector equations, parametric, and Cartesian. So we have a formula. It's called the scalar product or the dot product. So that's the symbol for the dot product. It's a way of multiplying vectors. And we have the product of the magnitudes times the cosine of the angle between them. It's called a scalar product because the answer is a scalar, or the product is a scalar. When we multiply two vectors, we don't get a vector, we get a scalar for this type of multiplication. So here's one type of question, one way of asking a dot product question. So here it says find the scalar product or dot product, and all we have to do is write down the formula and substitute. So we have the scalar product is the product of the magnitudes times the cosine of the angle. So the question is asking for the value of this, and we just have to substitute for that. Substitute for the magnitude of b, and then do cosine of 160. So when we multiply all of that, it's approximately negative 5.638. Another type of question is when we don't talk about an angle and it just says find the scalar product find the scalar product. So now we just multiply the vectors, and when we're not using the formula, we're not dealing with an angle, all we do is multiply 3 times 5 and then add it to 2 times 4. And this is why it's called a scalar product, because the answer is a scalar. 15 plus 8 is 23. Alright, and that's a similar question. Just find the dot product or the scalar product. Pause the video and try that. Pay attention to which component is missing here. So we have 3, 2, negative 1. And it'll be a 0, 5, 2. Now when we multiply 3 times 0, 2 times 5, negative 1 times 2, so the scalar product or the dot product is 8. Alright, and then using the scalar product, they can ask you to find an angle. Find the angle. So if it's ever dealing with an angle, either they give you an angle or say find an angle, then we need to have the full formula for the dot product or scalar product. And so let's just say this is going to be 1, 1. And this is going to be 2, negative 3, 1, 1, magnitude of 1, 1, and the magnitude of 2, negative 3, cosine of theta. So we're going to solve for theta. The dot product is 1 times 2, and then 1 times negative 3. Here we're going to square, square, square root, so it's 1 plus 1. Squared. This is going to be 4 plus 9. And we have negative 1. This will be 2 times 13. We'll do inverse cosine. And that is approximately 101 degrees if you round to the nearest degree. Find the angle between the vectors. Pause the video. So we do the dot product. That'll be 1 times 1, 0 times 3, 2 times 4. Here we have to square and square, so that's going to be 1 plus 4 and 1 plus 9 plus 16. And we have 9. We'll divide by this. And also do inverse cosine. And we should get 37.875 degrees is approximately theta. So this didn't say round it. If it doesn't say round it, just go with 3 decimal places. All right. Going along with finding angles is whether vectors are parallel or perpendicular. So A and B are parallel if A is some multiple of B. And that's called a scalar. A is a scalar multiple of B. Let's see what that looks like. If we have the vector over 1 up 2. So here's the vector 1, 2. And then we can draw, starting somewhere else, the vector 2, 4. So let's go down here, and then we're going to go over 2 up 4. This is the vector 2, 4. And we see that this vector is twice that vector. 2, 4 is a scalar multiple of 1, 2, and that means that they are parallel. And that's how we show parallel vectors. Let's look at A and B are perpendicular if their dot product is 0. And that's because the dot product depends on cosine. So if they're perpendicular and the angle is pi over 2, then cosine will be 0. So that's how that comes up. So here's a common question where they leave out one of the coefficients. So let's find x if A is parallel to B and if A is perpendicular to B. So if they are parallel, then we would have to have A being a multiple of B. That's 1x. That means that 3 has to equal k times 1, and also 4 has to equal k times x. So we can use this one to solve for k, and then substitute that to solve for x. And we looked at the horizontal component. The horizontal component, 3 has to be equal to k times 1, and also 4 has to be equal to k times x. So we have the horizontal component equation and the vertical component. We've solved for x. Is 3, 4 equal to 4/3 times, nope, that's wrong. Is 3, 4 equal to 3 times 1 and 4/3? So if we multiply 3 times 1, we get 3. 3 times 4/3 is 4, so that checks. We can see that they're parallel. Perpendicular vectors, their dot product is 0, so we would have 3, 4 dot product with 1x has to be 0. 3 times 1 is 3. 4 times x. And x has to be negative 3/4 for them to be parallel, perpendicular. Alright, similar question. Try this one. Pause the video. So finding x, if the vectors a and b are parallel, then we know that a is a multiple, scalar multiple of b. So that means 2 equals kx and 1 equals negative 3k. So k equals negative 1/3. And then that means over here we have 2 equals negative 1/3 x. So x equals negative 6. And they are perpendicular if their dot product is 0. So we just have 2 minus, whoops, that's an x. That's not an x. This is an x. So I'm going to start over. And 2, 1. And x negative 3 is 0. So we have 2 times x plus 1 times negative 3. 2x equals 3. X equals 3/2. All right. Parametric form. Alright, so these are vector equations, and this would be a point on the line, and this is just a multiple of the direction of the line. So if we look at the graph, we wanted to sketch this graph. It says start at 1, 3. And then go a multiple of negative 2, 3. And every multiple of this vector will be a point on the line. So if we just went left 2, up 3, left 2, up 3, there's a point on the line. We could also go right 2, down 3, right 2, down 3, there's another point on the line. If we even went half of this, that would mean we could go left 1, up 1.5, left 1, up 1.5, or right 1, down 1.5. So every multiple of this vector is a point on the line, and we can see the graph going like that. So that's how a vector equation works. It's like the slope-intercept form. So why don't we rewrite it as xy in place of r. R is a vector, and we'll just write it as xy. Alright. And then we just take the top row, x equals 1 minus 2 mu. There's the top row. All the horizontal components make one equation, and then all the vertical components make the other equation. And this is called parametric form, and that's called the parameter, and that's parametric form. Okay, so pause the video and do the same thing with this vector equation. Over 2, down 1 is the start, is a point on the line, and from that point we're going to move in this direction. This means over 1, up 5. Over 1, up 5. There's a point on the line, and we know the line is going to go through those points. And then we just write the horizontal components in an equation, vertical components, and that's the parametric form. Also, to answer this question, you don't have to do the graph, but this is the first time we've seen this equation, so we'll just understand what it means. But this is how we would answer. There's the answer to the question. All right, now we have vector form going to Cartesian form. So let's first put it into parametric form. There's parametric. We're going to leave it in parametric form, but we're going to solve for t. So it's going to be x minus 1, and then divide by -2. Solving for the parameter t, y minus 3 divided by 3. So there is still parametric form, but now we can just set these equal to each other because they both equal the same thing. And we just put it in whatever form we want. That is a Cartesian form. We can multiply by 3 on both sides, 3x minus 3. Multiply by -2 on both sides. And we'll have, we could put 3x plus 2y equals, we're going to add 3, that's 9. This is standard form. That's general form. These are all the different forms of a Cartesian form. We could also put it in slope-intercept form. So we're going to subtract 3x, and then we're going to divide by 2. And we don't have to put it in every, we don't have to represent every form, but just know the vocabulary because questions will ask you to do one of these and you have to have it in the correct form. So let's just make sure this is right. We have -3 plus 9 divided by 2. Looks good. All right. Pause the video and do this one. Parametric form. And then we set them equal to each other. Multiply both sides by 5. we'll just go to standard form. So we're going a little long. I'm just going to do one example here. Write in vector form. Well, to do that, all we need is a point on the line, and we need the slope, which will give us a direction vector. So we know there's a point. The point is -1 for the y-intercept. So -1, we know that point. We can just find any point on the line. That's an easy one to use. So the point is 0, -1. There's a point on the line. Okay, the slope is 1/2. This is rise over run, so we need to write the vector as horizontal and vertical. So just by looking at the slope, we know a direction, or the direction vector. I should say a direction vector, because it could be any multiple of that. And now we just fill in the point as a position vector, give it a parameter, and we can write it like that. We can also write it like this. That would be the same. That would be the same line. All right. So there's a common question. Find the intersection of lines given in vector form. Rather than converting them back to rectangular form and then finding the intersection, let's make sure we just are able to do it in this form. And we start by writing it in parametric form. 3 plus lambda, that's lambda. Y equals 1 minus lambda. Here we have -2 plus 2t, and y equals 3 minus t. This is equal to y, and this is equal to y, so that means these are equal, and these are equal. 3 plus lambda is equal to -2 plus 2t. This is equal to that because they both equal x. This 1 minus lambda is equal to that because they both equal y. And now we use elimination. We already have opposites here, so we can add, and we get t is 3. Let's call this equation A and equation B. And then let's go back to equation A to solve for lambda. 3 plus lambda equals, I'm substituting 3 in for t, and we have 3 plus lambda equals -2 plus 6. So lambda is 1. At this point, in the beginning, maybe you'll say the solution is 1, 3. Solution 1, 3? No, because those are the parameters. We need to find the x value and y value. So to find the intersection, let's use either of the equations. And that would be, we can use this or we can use that. So we have xy equals 3, 1 plus lambda 1, negative 1. Lambda is 1. So I'm copying the first vector equation and I'm putting in a 1, and that's going to be 3 plus 1 is 4. 1 minus 1 is 0. We did that with the first vector equation. We have 3, 1, 1, negative 1. Up here is 3, 1, 1, negative 1. All we have to do is substitute the value for lambda and then find the horizontal component by adding, and then find the vertical component by adding. Okay. If we use the other equation, we would get the same answer. Alright, we'll stop there.